But strings, I mean, okay, so the reason I think that strings were chosen is because these orbits are in the mesh of the universe. They're not strings, they're actually orbits. So, and you can if you really super, really wanted to, you can call an orbit like a string, because we do know that there's certain kinds of orbits that act like string. They like bind, and then you stretch and they pull back like that on I think they're called gluons, and there's others, but so that's like a rubber band effect almost. Anyway, we'll go onward. Space with no beginning and no end. If there is nothing in this space, then you cannot tell a large one from a smaller one. This would be how a formation of a universe could create a larger universe with less matter by changing the unit size of everything. If the density of space is zero, then the matter inside, so-called particle 1/2 second. I didn't really like that because I like to use science. I like to measure and weigh and balance, and I like it to be in agreement with thermodynamics and the second law, and all the laws should be in agreement. So when I was writing there, I would rather say it like what we see. What we see is this space, this time. We see space-time and superposition time. And so we see, and I'll even word it another way. We see space-time and we see superposition. And I'm saying that superposition is an out-of-phase time set. Let me see what I got here. So a particle like 1/2 the size would seem the same in the space, but would spin at different rates than a particle, say, in a different corpuscular time set. So time also could run at the same E = mc squared proportionately in each corpuscular time, but in relation to each other, one would appear to be in superposition. Can you say that's awesome? Oh my God. Oh, shivers. It may be that our black hole is being fed by matter falling into it, and this is expanding our space. I've gotten away from this idea. It's not impossible. This view has changed. It may be an optical effect. Now, I'll go into deep detail later on this, but right now, that's where we're at. A 700 nanometer hole and a red laser, and the resultant interference pattern is a space-time mass microscope that amplifies the motion of the virtual particles in superposition, which is the same as the ones trapped in the singularity at the moment they intersect with space-time, because the vertical particle is struck going around the middle point of the singularity that makes our space. And I was so struck with the beauty of it, I put beautiful. The single particle doesn't know it is trapped alone from its point of view. The mass of the black hole, resultant spin of the black hole, what is put into the black hole affects the resultant unitization of the space-time that creates that the black hole creates. We are going to peel back a layer of understanding, and at some point realize there is always another layer someday to pull back. The diameter of all particles would change the resultant time of that system. The diameter of all particles would change the resultant dual corpuscular time of that system. I was thinking of something else right at that moment when I wrote that, when I was reading that. Let's see. Oh, pull back another layer. We'll go on. There's so much to say, Okay. Oh, I don't like that one. because I don't have all my references in here. I'm going to skip that. It's a closed system universe where it's the bridge one that Einstein and they made, that just kind of a loop between two. Anyway, again, I'd rather look at what we can see rather than what we can, in this case, what we know. So, and the only thing we know is that we have a space-time that has a superposition, which is a dualistic corpuscular time set intimately connected. So there's two time sets to make a reality. Okay, and then as far as like doing stuff we don't know, I'd rather steer clear of that and stick with the stuff we do know. You could theoretically create different time rates. The black hole corpuscular time is massively faster than space-time, as it is in superposition, fuzzy, or imagine a skater with their arms pulled in, but in this case we have a rotating, infinitesimally small particle rotating at some speed we don't know. Because with the singularities, the diameter of the particle is, well, I made some assumptions here and I don't like that either. We would say the particle is infinitely small and its speed is still limited from its own point of view. So I got like, for instance, a little, it's going to need, more development. Matter of fact, if you have a science and you see this connecting with it, that, I mean, it could take a very long time to take the base of this and connect it up to other things, because I'm just talking about, I'm taking all of the sciences and the measurements, and what I saw was like a bunch of dots on a page, and it just made sense to me that this was the truth. And so this is what it explains a lot of things. We're going to get more into that. V particle superposition in the black hole, normal space. When a V particle collides with a normal space-time under the right conditions, a particle forms. V particle is a virtual particle. That's the way I was describing it at that time. Two entangled particles spread apart are an entangled virtual particle spot in the singularity. One going up, the other the opposite. Then it makes perfect sense. And I interjected this here. 700 opaque matter, a 700 nanometer opaque matter interacts with light, changing its trajectory like a microscope. This explains why big particles at the same, big solid particles act the same as the light particles. So they've done interference patterns with literally solid matter. Their interaction is in sync and shows us that result. So pseudo light speed would likely reveal another pattern. Interesting. Basically, you take your laser and you make an interference pattern on a wall that's at a distance, and you rotate it around at a pseudo light speed. It's not really light speed, but when it hits light speed, I would predict that would create a pattern. And I calculated how fast it would have to be. It's fast, like incredibly fast, and the distance is quite a ways. So it'd be a big job to make that. I don't know. It's probably possible. Each entangled particle is on a frame of its own. Let's see. Yeah. Each entangled particle is on its own frame of reference. In other words, every particle is falling to the center of the black hole, captured by the black hole, and is alone in the black hole on its own frame of reference. But within the space particle, it gains its own degree of freedom. And apparently, the system doesn't care, and it as far as the system goes, it's still captured. Two entangled particles are on two frames right next to each other. And these particles are in a dance when one is going down, the other is going up. If you remove one of the particles, then the dance is over, and the remaining partner will continue in the last direction, which happens to be the opposite, of the other particle. In particle space, you can move these two apart because the particle is basically the space particle is one particle, but each Planck length of that particle is also one space particle. With saying that, in particle space, you can move these two apart, and it's just a trajectory change in the singularity, explained more later. Now, a corpuscular time forms outside of the smallest interactions in our space. All singularity gravity is cancelled because the space particle is in the center of the singularity at every point down to a limit which is likely the Planck size limit. Gravity leaks through anything smaller than that, and this small leakage is called the weak force. It's ingeniously designed to